This will be for the con exercise. Use the properties of logarithms. So the first rule we have to know is the product rule. Okay, so it is the log of m times n equals the log of m plus the log of n. All right, notice that in all cases on both sides of the equal sign, the base b does not change. Okay, so the base has to match here, here, and here. All right, so just as an example, if you did, let's say you did the log of 12. All right, and just by the way, if you don't write a base number here, it's automatically base 10. So the one on your calculator is base 10 when you press the log button. Anyhow, the log of 12, that's actually the same as the log of 3 times 4. All right, and that is equivalent to the log of 3 plus the log of 4. All right, I ran out of room. Let me fix this. So the log of 3 times 4 equals the log of 3 plus the log of 4. All right, and you can do this backwards as well. If you have the log of something plus the log of something, that's going to equal the log of those two numbers multiplied by each other. All right, so it goes either way. All right, next up is the quotient rule. The log of m divided by n equals the log of m minus the log of n. Okay, notice once again that the bases on both sides of the equal sign match. All right, so as an example, if you had the log of, let's say, 9 halves, or 9 divided by 2, that's the same as the log of 9 minus the log of 2. All right, you can test that on the calculator if you want to prove it. But anyhow, again, when there's no base on the log, it's automatically base 10. And really, this would work as long as all the bases of the log match on both sides. And one thing you want to be careful with the quotient rule, you want to remember that the log of a over b is not equal to the log of a divided by the log of b. All right, those are two different things, so please be careful. All right, finally, the last one is the power rule. The log of m to the power of p equals p times the log of m. All right, so basically, you can take the exponent and move it out front. All right, so let's say you have the log of x to the third. You can take that exponent and move it in front of the log, and you'll have 3 times log of x. All right, so those are equivalent statements. So if you had the log of, let's say, 5 to the third power, you can take that exponent and move it to the front, and that's equivalent to 3 times the log of 5. All right, they want us to rewrite the following in the form of log of c. So if you recall from before, The log of a times b, or you can say m times n, same thing. Log of a times b equals the log of a plus the log of b. All right. So since these are added together, this is your a and this is your b. So we can make it equal to the log of a times b or the log of 5 times 3. All right, so a was the 3 and b was the 5. And that is going to equal the log of 5 times 3, which is just 15. So just click in the box and you can type log or click the log button and type 15. Okay, if you want to use parentheses, you can, but you don't necessarily need to. So it's just the log of 15. No base, it means base 10, but the originals didn't have the base either, so that's it. All right, they want us to rewrite this in the form of log of one number. Okay, if you remember the quotient rule, the log of a divided by b equals the log of a minus the log of b. All right. So since we have two logs subtracted from each other, we can use this rule. Okay, clearly this one is the a and this one is the b. So it's going to be the log of a divided by b. So that's going to be the log of 4 divided by 2. And of course, we know that 4 divided by 2 is just 2. So that's it. So just click in the box. You can type log, or you can click the log button right here. Log of 2. All right, they want us to rewrite this in the form of the log of one number. So for this one, we're going to use the power rule. Okay, if you have the log of a to the power of b, you can take the exponent and move it to the front. So that's equivalent to b times the log of a. All right, so in this case, we're just working backwards. Okay, clearly b, the number that is out front in the front of the log, is the number 4. And the thing we're taking the log of is a. So we're going to translate it to this right here. That's going to be the log of a, which is 5, to the power of b, which is 4. Okay. And I don't know if they'll accept the answer like that, but just in case, let's see. 5 multiplied 4 times, that's 25 times 25. I think that's going to be 625. Let me check on my calculator real quick. Yeah, 625, so that's it. All right, I'm going to try to enter it like this. I want to see what happens, but then I'll do this answer here. All right, let's see if we write log of 5 to the 4th. Log of 5 to the 4th power. I want to see if they accept it. Okay, it says not quite yet, so they won't accept it. They won't accept it like that. You have to multiply it out. So 5 to the 4th is equivalent to 625. Log of 625. All right, so just make sure you don't leave the exponent in your answer.